Good morning, everyone. This is Sachin Fiske, Electrical Engineering Department, SND College of Engineering and Research Center. Today, we are going to start the AC motor starter by using a PLC system. Let us see some input connection or input terminology related to PLC starter. So, this figure A indicates the AC system in which two lines are given, that is L1 and L2. This L1 and L2 will represent the phase and neutral representative of the system. Here, some modules are given, that is 1, 2, 3, and ground. Generally, for phases, that is R, Y, and B, these modules are given, and in between them, we have to connect some NO and NC contact. In case of a DC system, in figure B, some source will be given, that is positive and negative, but where it is necessary to connect the ground terminal as PLC supply will be there. It is just similar to that of the figure A, that is for AC supply. And TTL terminology will be given. Basically, in case of the DC supply, some transistors can be used in case of the PLC system as DC supply is there, and it is again very similar. But in case of the ground, generally we are using a positive voltage and negative voltage terminal to complete the circuit. This is the overview of the PLC when connected to an AC motor. Basically, one side, that is left hand side of the PLC, indicates the input module, while the right hand side of the PLC is known as the output module. Here, the input modules are connected to the input devices, just like the start button, push button, stop push button, and towards the output module, generally the electrical applications, just like motor, lamp, or contactor or solenoid, can be connected. The basic objective to use the starter to run this motor is to control the speed of the induction motor or AC motor by using a PLC system, to control the torque or to maintain the efficiency up to 95% of the synchronous speed, and showing all these results in the SCADA screen is the main objective by using PLC. Now let us see this block diagram of the PLC. In case or in simple starter or simple AC starter, basically a three-phase supply is given to the starter, and the output of the starter will be given to the induction motor, and motor will start to operate. But in case of the PLC system, such a type of block system can be used. Means when three-phase supply is given to the SFU. What is SFU? SFU means switch fuse unit. And here, switch fuse unit, what basically consists of? So it is the combination of the three electrical applications, that is HRC fuses, contactor, and a relay. So as the start of this three-phase supply, it is given to the three HRC fuses, that is R, Y, and B. And the output of this HRC fuses will be the input to the relay system. That relay system is known as the overcurrent relay. The output of this overcurrent relay will be given to the contactor, and at the last, the output of this contactor will be given to the rectifier system. So all this combination of HRC fuse, relay system, and contactor combines together to form a single unit, and that single unit is known as switch fuse unit. So three-phase supply is given to this switch fuse unit. Now the output of this three SFU is three-phase supply, and it is necessary to give this supply to the rectifier, as the most common function of the rectifier is to convert the AC supply into DC, and it is needed because we are going to control the speed of the induction motor by using PLC, and our PLC will be operated on DC supply. So we need a basic DC supply by converting and by using this rectifier circuit. But The motor is AC, and that's why again we have to convert the DC supply into AC for the transmission of this motor or induction motor, and hence we are using a simple PWM, that is pulse width modulation inverter here. Means a combined rectifier cum PWM inverter can be used to run this motor, and from this rectifier circuit a PLC can also be communicated bidirectionally. Now here the major important part is that how this rectifier cum PWM inverter works together. So the combination implies that it is a variable frequency drive, and by using this variable frequency drive automatically the voltage can be turned to a DC supply or AC supply as per our requirement. Now let us take one example. If the fault occur on induction motor, or if we have to conduct the maintenance on induction motor, and at the same time we have to operate this motor from the operator side. So the PLC can be programmed by using a computer operator, and hence, it can be operated easily by using this PLC circuit. So at the same time, we can control the induction motor by using PLC from the computer operator. It is very easiest process. During this operation, generally by using a VFD system, a variable frequency, variable voltage method can be applied. Means it is a V by F control method, and during the use of this V by F method, this ratio must be maintained constant. Now here, how this ratio can be maintained constant? So voltage can be automatically adjusted by using a rheostat system or by using a simple terminology system. But at the same time, here generally we can control this frequency by using a tabulation form, and during this tabulation form this ratio can be maintained very easily by proportion of the voltage system. In this way, basically by using a PLC system we can control the speed of the induction motor, and at the same time the wiring contact between PLC and induction motor can be reduces very shortly. It increases the efficiency of the induction motor up to 95% of the synchronous speed, and hence the speed of the induction motor can also be increased. In this way, the starter can be worked by using this PLC system. But if we can't use this PLC system, the speed or efficiency of the induction motor can be very less, as it is 60%. Thank you.